All right. Good morning, good afternoon, or good evening, everyone. We're going to get started on today's webinar. My name is William Chan. I'm the co-founder and CEO of Compass Analytics. And today, my colleague Ethan, Scott, and I are very excited to bring to you the continuation of our Dataiku webinar series. This is part 4 out of 15, with today's session being called Building Your First AI Project. Now, a bit about Compass. We are a data analytics consulting firm based in Canada, and one of the principles at Compass is teachers first. We firmly believe in educating our clients about all the possibilities, and we take the time to break down the high-level concepts, which is why we're bringing this enablement series to everyone. Now, before we get into the content, a brief introduction to ourselves. My background comes from aviation and pharma, where I've worked on digital transformation projects before, helping organizations make the most out of their data. So from data strategy to engineering and Gen AI and everything in between. We're proud partners of Dataiku here at Compass, and we've really seen the power of Dataiku in the hands of our users and clients, and hope you find the same today. If you don't have Dataiku installed, you can download a free 14-day trial from their website. And if you're a student who's watching this, you're eligible for a 1-year trial. So with that said, I'm joined today by Scott MacIntosh, who is our head of sports and entertainment based out of Toronto. Scott has over 15 years working on the team side, working with franchises like MLSC, the Ottawa Senators, in a variety of different functions from BI analytics to revenue and technology. Scott was previously the former SAP and North American lead, and basically has been on the team side and all the tech side, working with groups like the San Francisco 49ers, Bayern Munich, and Big Four leagues like NHL and the NBA. I'm also joined by Ethan Pirso, one of our AI consultants based out of Montreal. Ethan has 5 years of data science and machine learning background from a variety of different industries, from pharmaceuticals, consumer goods, and healthcare. And Ethan will be anchoring our webinar today. So uh, at this time, I'll turn it over to Scott, our head of sports, for a rapid state of the union on sports, followed by Ethan, our AI specialist, to take on the rest of the demo. Scott, over to you.
Yeah, thanks, Will. So for those, I mean, it's a mixed crowd on the call today. There's those who are working in sports, and those in the industry. From the outside, it probably appears like the sports industry has a lot of money to spend on the business side, but the reality is there's a bit of a gap between the people and the use of technology. The entertainment industry, be it sports, be it media, with all of its advancements in fan engagement, player operations, smart stadiums, digital fan experiences, new content and interactions with fans, there's a really, really rich back end in terms of data. But the challenge for a lot of these organizations is that they lack the sufficient personnel resources to really take advantage of this. And that comes from really an underinvestment in people and an inadequate understanding of technology, which leads to a bit of a reactive environment. When you just don't have enough personnel to take on all the projects that you need to get done, you start to react and do them a little bit halfway to try to get some results. You use quick fixes, you might buy really large scale, what we call point solutions that solve a single problem, rather than really building an effective back end with a solid data infrastructure that allows you to really take advantage of some of the technology solutions that are out there and the access to the data that you already have. So where does this kind of come from? A lot of it's legacy systems and improper technology setup. A lot of sports teams, they're much smaller than you would think. This is the same for other industries, where you've got older systems that don't really interact with and share data across different areas and departments. So you have a lot of data silos inside these organizations. And it really stops you from really getting access to some of those real insights that can change the success and the efficiency of how your business is running. So in sports, that lack of people resources, it doesn't come from a lack of talent, because there is a ton of it there for those of you that are in the medium, managers, director level. You've grown up maybe in industry, maybe outside industry, And you've got the talent to take advantage of some of these things, but you may be tasked with the wrong resources from a technology perspective, or just the inability to spend money. So you're on so many different projects and you really don't have a chance to be efficient. And there's not a lot of automation set up. So what we're going to walk through today is really, some solutions to try to help you do that in a little bit of a more efficient way. And inside your organizations, there's an increased demand for insights. You're starting to do projects for your operations teams, your sales teams, your marketing teams, some even on the player development side. And each department is asking for more and more insights as they see what you can deliver. So that's where a tool like Dataiku and really doing things in a more automated way and getting your back-end data infrastructure set up the right way is so important. So you can use some of these tools and get some of the insights that you need to kind of move the organization forward. So I'll turn it back over to Ethan, who's going to walk through our presentation today.
Awesome. Thank you so much, Scott. So let's start with the big picture for Dataiku. It's all about unlocking business value with really no code or low code solutions, although Dataiku also excels in high code. Dataiku just makes AI so accessible to business teams by removing the technical barriers. So with no code solutions like the one you're going to see today, teams can contribute directly to AI projects, accelerating insight generation while reducing dependency on technical resources. Now, let's talk about how we bring that to life. Today, we're going to walk through a live demo of how we use no-code AI to extract survey insights in sports. The solution pulls key themes from game day fan comments using LLM visual recipes, a powerful, intuitive way to generate insight fast. In addition to our demo, I just wanted to highlight 2 other client success stories and use cases that we're also going to touch upon in future webinars. And those are pharma sales forecasting. So clients using time series visual machine learning in Dataiku to predict sales trends and set targeted data-driven goals for brand reps and leaders. And then demand forecasting. So companies that are leveraging Dataiku's built-in solution to predict product level demand across regions, boosting accuracy and supply chain efficiency. So together, these examples really show how no-code and low-code solutions for AI in Dataiku really empower real-world impact across many industries. Now, why should you really use Dataiku, and where does it exactly sit within your enterprise? Well, it's the best AI and ML engine out there that gets you from your silver layer data to your gold. And this, of course, comes after you've done your data engineering, you've built all your data pipelines from bronze to silver. Dataiku makes it really easy to connect all those sources. From there, Dataiku excels at performing any last leg ETL and data prep before building and deploying your AI ML models. And all of this is done in one centralized platform with centralized governance as well. And then finally, the output of your AI and ML projects can be seamlessly connected to your end user business applications like dashboarding tools such as Tableau and Power BI. Now, what exactly is Dataiku? Well, it's a centralized analytics workbench that lets anyone collaborate on projects regardless of their technical skill. So this means a business analyst with no coding knowledge can collaborate on the same project that a data engineer is working on, writing Python, SQL, or really any other language that Dataiku supports. Now, what does it look like to collaborate on a project? Well, what you see here is called the flow. And this is where everything really happens in Dataiku. It's where you connect your data sources, perform your data preparation and transformation steps, build and deploy machine learning models, all in one visual interface that's easy to follow and anyone can understand. And finally, Dataiku is cloud agnostic, meaning it can be deployed, the instance Dataiku, across all your major cloud providers and integrates connections from really any data source. There's 50 plus built-in connectors and file formats supported, and of course, popular lakehouse architectures like Databricks and Snowflake. Now, before we actually kick off the demo, let's quickly cover some key Dataiku concepts that will be really important to know today. So there's three things that we're going to be working with our demo that we all see in the flow, and those are datasets, recipes, and flow zones. So datasets are those blue squares you see, and the icons inside the blue square indicate what type of data the underlying storage comes from. Like I mentioned, there are over 50 plus data connectors and file formats, and any connectors that are not natively built into Dataiku. If your database or cloud provider provides a JDBC driver, it is possible to connect to in Dataiku. There's also ways to do API ingestion, which is really cool as well. So then we have recipes. The key ones we're going to focus on today are the yellow circles, pink circles, and green circles. And so the yellow circles perform the most common types of data processing and transformations like data prep, grouping, joins, and they're all done with a really easy, simple graphical user interface. Then the pink recipes that we're going to look at today are the LLM or large language models that let us do really cool things like send a prompt and evaluate a prompt for each row with text in our data, or perform sentiment analysis, which we'll see today as well. And then finally, the green circles or diamonds that you see on a flow are models. So when we look at fan segmentation, we're going to see a clustering model today, and that's in green. The last thing in the flow that I want to point out is flow zones. These just help improve the clarity of your flow. So they are these kind of rectangles that are grouping different parts of the flow together, like your data ingestion could all be grouped. Then you do your data preparation, your modeling, just makes it really easy to follow and improve the view of your project. Now, what we'll actually build today. So fan feedback to game day strategy with Dataiku is the business scenario. And we're going to be working, this is a made up scenario. So a new NBA team, the Montreal Voyageurs, has gathered thousands of post-game surveys from new fans and attendees at their game. And they're struggling to turn that feedback into fan experience improvements. So the open text comments are really tough to analyze, especially at scale. And then fan segmentation remains a challenge. So the different data types we're going to see, there's structured survey data with attendee comments. So it's all tabular, but there's numerical, categorical data, and then also just free text. And our goal today, our response and the outcomes, we're going to use Dataiku to build a no-code workflow that will clean this data, bring it all together, and summarize the open text feedback with LLM recipes. We'll do some sentiment analysis to get a better idea of how the fans feel about their experience, or maybe some other factors like the food at the game. And then we'll also do a visual ML in Dataiku to do fan segmentation. Now let's jump over to Dataiku and actually check out the project and walk through the demo. All right, so this is Dataiku. The project that we're going to be working in is Sports Survey Insights demo, and we're in the flow already. Now I'm just going to navigate over to the dashboards and open this up to showcase what we're going to build through the data pipeline that we're going to make today. So this is the final dashboard. We see some KPIs at the top, like the number of survey responses, the average game ratings, and then we have an average fan rating by game date. So a time series, we can see how our fan experience is evolving over time. Then just some information about the scores and the outcome of the game. So Montreal versus opponent score in this radial graph. And then we did some sentiment analysis. So we see this Sankey chart showing that, okay, looks like when Montreal Voyageurs win, most of those sentiments are positive. You can also analyze the sentiment when an opponent wins. They're more neutral or actually negative. That kind of makes sense, as a home fan is probably going to be a bit happier when their home team wins. Then we've also gone ahead and summarized by each game all the fan comments. So this is a really powerful feature of two recipes actually that we combine in an aggregate analysis: the grouping recipe and then the summarize text LLM recipe. Then we also have a few other visualizations for fan sentiment, just a count of all sentiments in the comments, and then also that broken down by game. The second dashboard is actually our fan segmentation insights. So this provides a full report of the clustering, and we'll go into this a bit further, but the Dataiku is just an incredibly powerful way to do any kind of modeling through what they call visual ML, or visual machine learning, and the explainability and reports that are provided after are just fantastic. Like here we we did k-means clustering. That's just a way to do segmentation. Dataiku actually will kind of analyze the results of your model for you and provide these simple, explainable observations in plain text that anyone can understand to give you a better idea about what's actually happening in your data. Now, let's jump back over to the flow and talk a bit about how we got there. So everything starts in this data ingestion flow zone. And this is where we're inputting 3 data sets. So we have survey responses. Down at the bottom, I can preview my survey responses. And so this contains an ID for the response, game, and fan, and then some information like the stadium section the fan was in, and then how they rated the game, the food, the entertainment, and then there's a free text comment that has been written here. And this is synthetic data that's been created for the purpose of this demo also. And then also just a timestamp. Then the game details. So this is just more specific details and data about the game, like the specific game attended. This is the opponent. Then whether there was a promo running that night. So if there's a student night, if it was what type of season, regular, pre, playoff, the attendance, if there's a concession special, the winner, and final score. Then the last data set that we ingest is the fan profile. So some more information about who actually wrote the survey and who attended the game, their age, gender, if they're a loyalty member, where they came from. So Montreal, Quebec, Ontario, other are the options in this data set, and then their preferred seat. So what we do in this data ingestion flow zone, first, these were all just file extracts, but the way that we can add data sets and how we added this was going to the plus dataset dropdown here. And you can either upload from your file system, which is what we chose to do. There's also options to connect all your SQL databases, cloud storage, and NoSQL as well, which is really awesome. So you can really bring any kind of data from any resource into Dataiku and then start working with it. So we also used the sync recipe. Now, quick overview of how you get to a recipe. So when you click on a data set, there's this actions panel that we can open. And from there, you can see all the available recipes that are available that you can perform on your data set that will connect one to the other and perform your processing logic or your transformation steps. And this sync recipe, essentially what it's going to do is pull and copy the most recent data from your data source into your flow. This is especially helpful when you want to move data from one source to another, like SQL to file system or vice versa. So now that we have a copy of all our data in our flow, we're going to go ahead and join all that data. So to do that, we've used the join recipe, which is available in the visual recipes here. When you click on a data set, you can join data. And so we've already done that in this demo. So when I double click into the join recipe, this is the graphical user interface that will allow you to make a join. When you input and initially use this recipe, there's going to be 2 inputs. And then to add a third data set that we want to join, we can simply use this plus here to add a new data set to join with our survey responses. Then there's also the conditions. So Dataiku, this is one feature of Dataiku that's fantastic that you wouldn't get if you're just writing SQL, for example, is Dataiku automatically recognizes primary keys and foreign keys. So those are just the common columns between your data sets that you can actually join on together. So it's already recognized that there's a fan ID in survey responses, there's a fan profile or fan ID in fan profile, so it'll join the data sets on that condition. Then for survey responses and game details, it automatically recognizes that there's a game ID in both data sets as well. Now there's also this drop down to choose the type of join. And so if we were using SQL, we'd have all the options, but for file system data right now, we could do left join, inner join, right join, cross join, and then there's some even advanced options here. But it's a fantastic and easy way to join data completely, no code, and performs all the type of joins that you could do, whether you're writing in PySpark or SQL, completely replaced by this graphical user interface and makes it easy so anyone could do this. Now, the second step here after joining the data and setting it up, making our conditions, is to select our columns. So by default, Dataiku will select all non-conflicting columns. But we can actually change this to select all columns in our data set or manually select which columns are going to be in the output. So Dataiku, it will just get rid of the foreign keys from the other data sets that you're joining onto so that there's no duplicates. But you can also just go ahead, select on and off different attributes if you don't want them to be in your output data set. Then when you're done setting up and configuring a recipe, there's usually a run button on the bottom, and we're just going to be using DSS engine because we're working with file system. But when you're working with SQL or cloud data, you can set this to actually run in database, and the output of this recipe would actually get translated into a SQL query that gets pushed down to your underlying data infrastructure. So that is the join recipe. Now, the output of that, once we've joined all our data, is going to be this flattened data set. If I go into it, it just has all our attributes now, just in one data set. And you see there's some missing values, some errors, a lot of missing comments, and it's a little bit messy still. So what we're going to do is data prep and LLM enrichment now. And the first step of that is going to be to utilize this prepare recipe. And this is where you do all your data preparation and your data cleansing steps in. So the prepare recipe has over 90 data processors that if I add next step, you can see the processors library. They complete all your tasks like filtering data, cleansing, working with strings, numbers, enriching data, working with dates. And there's even a code option if you want to do row-wise or column-wise operations with a Python function. You could do that too. So now how do we actually do all these steps that we've computed already to transform the data and just clean it up a little bit? Well, from the dropdown on each column here, Dataiku will automatically recommend which processors to use. So process with the formula, or here, so process with the formula, we've already done them, but sometimes it'll say fill missing values if there are missing values. You can also get the automatically recommended transformation steps when you click on a particular entry. So here it's suggesting, okay, for this entry, I clicked on rating game where it's equal to 1, and it's giving me the option to add that step to maybe remove rows equal to 1 or keep only rows equal to 1. So it's just going to make your data preparation and cleaning a lot faster by giving you these recommendations to the most common types of cleansing steps that a data science or data analyst practitioner will usually make. And what we've done in this prepare recipe is we filled the some empty cells of rating entertainment with the average value of ratings. Then we've also split the score. So this is working with strings, regular expression. We've also filled some empty cells of comment with no comment, so we don't have any more empty values. We're doing that for a few more columns as well, like the stadium section, the concession special. We're just filling these with a new value so that we don't have any missing. And then similarly for age and attendance, those are numerical values. We're just doing imputation with the average age and attendance. So another really cool feature, if you don't want to manually add all your steps or you can't seem to figure out which of the 90 plus processors to use, you can use this generate steps feature, which uses AI to help generate a step. You just need to explain the data transformation that you want to make, and it understands the schema of your data. It will be able to read a few rows and get an idea of the type of data and values in your data set. And then it will prescribe the data transformation step that you want to make based on what you've asked and add that to the preparation script here. Then once you're done, like other recipes, you'd press run and you'd get the output of your clean data set. Another interesting thing is just the grouping. So what we did here is split scores, and it was actually 3 transformation steps. Way to group is if I wanted to, let's say, just group all of these comments and press this actions, I can say group, and I will call this fill missing data. Done. Now it's a little bit easier to follow, and some steps are hidden, so it's easier to use. Jump back into the flow now, and we'll cover the next step, which is LLM enrichment. So the output of joining the data, now we've prepared our data and cleaned it a little bit. We're ready to use AI. And this first recipe is really, really cool. It is called a prompt recipe. We're going to jump into it. And I mentioned previously in our data set, some of the comments, we have a free text column. And because this is the Montreal Voyageurs, we're expecting some comments to be in French or English or multilingual. So we just want to standardize our data for making it easier just to work with. And when we put it on a dashboard, it'll be easy to consume for anyone. And we're using this prompt recipe to translate any comments in French into English. Now, in this prompt recipe, we have our option to select which LLM we want to use. So that is here. That is the first step. And then you would write your prompt that you want to run. And this does the prompt on each row in your data set. Then you'd give your LLM the different inputs. So we're just giving the comment column that contains our free text, and you can add a description. The LLMs are pretty good at understanding those, so I just wrote comment. And then you can also provide some examples for one-shot or few-shot learning, and this will just improve the output of your LLM. If you give it a few examples, it kind of understands, okay, this is what the user really is asking for. And then the last step of the prompt recipe are just the LLM settings, which we're just going to leave default here, but you could change things like the temperature, which is kind of like changing how creative the LLM is. And then there's a few more options as well. Now, this was actually the second iteration of a prompt. And what we did is we can jump over to Prompt Studios. And I can find it in this navigation panel here. If I go over to Prompt Studios, French to English, this is how we created that prompt recipe. The first time so this is the prompt we actually used. But the first time we did it, we didn't really get a great output. Just told the LLM if a comment is in French, translate it into English, otherwise do nothing. And we gave it one input, but we didn't give it any examples. And this is just a fantastic place to test your prompt and see if it's working, because we tried running this, and when we do it here, it gives you kind of a weird output. So if it's already in English, it just says no translation needed. And then if it's in French, it was adding this like comment, which I didn't really like. So we added another prompt to compare. And this time we just gave it stricter instructions, avoid quotations, simply translate and return comments in English, or if they're English, just simply return the English comment. And then we gave it a few examples. And now when we run this, our output is going to look a lot better. So this tool in Dataiku, Prompt Studios, fantastic, easy to use, and it makes working with LLMs and prompting LLMs a whole lot easier. So the output of this recipe, when we preview it, there is going to be a few LLM columns, but the final LLM output from that recipe is in this LLM output column. The next recipe that we're using is this classify text recipe, and this is going to help us perform sentiment analysis. So those comments that we read, we want to know now if they're positive, negative, neutral, or mixed, which you saw in the dashboard. Now, this is the recipe that's actually going to enable us to gain those insights. So when I jump into the recipe, there's only 4 settings. It's very easy to use. You select your LLM, then you provide an input column. So we're just using that comment as well. And then there's actually a few different tasks you can choose from. So the classified text recipe isn't just for sentiment analysis. You could also do emotion analysis to understand the emotion behind free text. And then there's also an other option. That other option gives the user the ability to create their own categories that the LLM will then classify your text into, which is really neat as well. And then finally, there's a couple options for the output mode, either outputting the most likely class or all the classes. So that would be like a JSON output where for each positive, neutral, or negative, there would be a probability that all sum to 1 about which, the probability that this comment is positive. And if it is a positive comment, maybe only 80%, and then maybe it's 20% neutral. So if we output the most likely class, we would just see positive in our output, or we could see all those probabilities if we wanted to dig deeper and gain more insight on the comments. That is an option too. Now, the way this prompt works is it is actually just a managed prompt in Dataiku. And if I show what that looks like, so the prompt that's being used to perform the task, it's already pre-written, and we can't modify it here. There's also a description, so the text to classify, it's that column that we input in the recipe settings. And then Dataiku already has provided a few examples to the LLM for it to use. We could also take this prompt now from the classify text recipe and convert it into a prompt recipe if we needed to modify and we wanted like a very customized version of our sentiment analysis. Maybe we want to add a few more sentiments or possibly extend the emotion analysis. If we were doing that, that's also an option. I'll jump back into Dataiku. We'll check out the output of that in the survey sentiment data set. So I'm navigating this in the preview below, which makes it really easy. And then if you see here, we have this new prediction column where we're seeing our negative, positive, neutral, and mixed predictions that the written comment are. Now, finally, we're going to use one more prepare recipe just to clean up the output of the LLM recipes. So we're just going to remove a ton of columns like LLM error message. We previously checked them. Looks like the LLM worked really well. So we don't need any of these columns anymore, but they would be great. They would be great if you wanted to do some kind of like, gain feedback on how the LLM is using or just is working, or evaluate the efficacy of the LLM. You could use these columns. For now, we're just going to remove these. We also rename the 2 LLM outputs and prediction columns back to our comment and sentiment that we can work with downstream. So the next flow that we're going to look in after we've done the data prep and LLM enrichment now is the aggregate analyses. So we're just copying this survey sentiment prepared over to the next flow zone. And we're going to use this group recipe. And we want to get a better understanding of, the final output of this is going to be to summarize all the survey comments by each game. So we can see, okay, by each game, what is the sentiment? What are like the survey summaries? And this is the first recipe step in doing that. So for group keys, this is going to be where you select which columns you want to group your data on. And you could group on one column. You can add more keys if you want, and really just group on as many number of columns as you have in your data set, I guess -1. And then you can also compute the count for each group, and that just provides an additional output from the recipe. Will just be a count of how many rows went into that grouping. Then we have our per field aggregation. So for each attribute that is not grouped on, like the game attended, you have the options for strings. You can check out you can count the distinct values, or the min and max count, the first value that appears in your data set, the last value that appears in your data set, or you can concat all the values that appear in your data set together in the final group output. Then for numerical values, we have a few more statistics like average, median, sum, standard deviation, and count. You can also, for each attribute that you're doing aggregations on, you can select as many of these aggregations as possible, or you can just do one aggregation, or if you don't want a particular column in your output, you don't have to do any aggregations. When we look at our output, this is what we see here. So the output column names, we can easily override and rename that if we want, but it automatically appends to each column that you're doing a aggregation on the type of aggregation. So for game rating, we are doing average. Dataiku just appended that underscore AVG there for me. So it's really easy. I don't have to do anything else. And then the last column we discussed, we're going to output the count of the number of rows that went into each grouping. I'll jump back into the flow and let's check out the output of that grouping column. So now we have our game attended. So there's 1, 2, 3, 4, 5, 6, 7 games here. Then the rating broken down by each game. For game rating, food rating, entertainment rating, we see the average number of attendees, the average score that Montreal had against that opponent, the average score that the opponent had against Montreal, the average age of attendees. And then finally, we've concatenated all the different comments together that we're going to provide to the summarized text LLM recipe. So let's look into what that recipe is. When we go into the summarized text, we have only 6 settings. So again, really easy. Dataiku is making it so simple to work with LLMs. The first option, like all LLM recipes, is just going to be to select that LLM. Then you provide the input column. So we're getting that comments concat, which are all the comments for each game strung together. Then we're providing the summary language. This is an optional output. And then we can set the desired maximum length of our summary. So we're just going to provide 2 sentences as our input, and hopefully we get 2 sentences output from the LLM. Like the previous recipe in classify text, this is also a managed prompt in Dataiku. So we could just as easily show the prompt, see what's actually happening under the hood and getting passed to the LLM. And then, like we could before, we could convert this to a prompt recipe if we want to do something really customized to summarize our text. And we could manage this in prompt studios. And again, it's just so easy to work with LLMs. Now let's finally check out the survey summarized data set. So most of the columns have not changed, right? Because we're just summarizing the comment concat. So these were the previous comments, they're strings, and now we have a summary column right here. And this is going to be the summary of all our columns by every game. And that's one of the insights that we see on the dashboard. If we look at one, it's broken down kind of how the fans feel. And this is a great kind of like executive overview level of where your fans' heads are at, when they're leaving a game, how do they feel overall? And this will be really great for prescribing ways to improve the fan experience. Now let's look in fan segmentation. This is where we're going to be using Dataiku's visual ML features and do some clustering. So if I navigate in the top navigation panel to the visual ML analysis, this is what's called the visual lab, Dataiku's lab, visual ML. We have this clustering surveys lab, and it's part of the AutoML capabilities. So when I choose a clustering lab and I want to do fan segmentation, Dataiku automatically chooses a few. So we chose the k-means model, and then Dataiku will suggest a few hyperparameters of the model. And then the way that the model gets trained and you actually evaluate against different hyperparameters, the interface looks like this, which looks similar to other visual machine learning or MLOps tools available on other platforms that you may have seen, like MLflow. And it's a very easy way to understand what's going on, how the models are being trained over each kind of epoch or iteration. But the important thing here is we have a model, and the best model when you do a training session is going to be indicated by this little trophy. So this one was the best, evaluated on a silhouette score, which is a very common metric used in clustering. And so we're going to go ahead and deploy this model. So when I jump into that model, the first thing I see is the summary. Now, this is what I was talking about before, the different types of observations available that I didn't have to do anything other than train the model, which was done with a few clicks of the button. And Dataiku will take the output of the model and then provide me observations so that I can, just quickly get some impact and insights. So here it's telling me for cluster 0, the age is 50% greater than the mean, and looks like it's about 40% has the floor as the preferred seat. So older fans prefer to sit closer to the floor. And then another interesting one was the food rating in this cluster was also about 40% less than the average. So this is a very interesting segment. Maybe they're older fans and they prefer to sit on the floor or closer to the game that's happening. And then it's also telling us that the food wasn't great. Maybe this means the fans closer to the floor just expect better food, or maybe the food in upper levels is actually better. And that could be something you can take back as team and do some further analysis on and investigate. So the different types of observations you're going to see broken down for each cluster. This is each fan segment, really, or attendee segment. And then there's also a few visualizations that are really interesting. Like we can look at the feature importance. So how important each attribute in our data set was for differentiating which cluster a particular fan survey would go into. Then we could look specifically at the clusters. So a heat map of the different features, and then how low or high their significance was in determining which rows would actually get added to that cluster. We could also look at cluster profiles. So by each feature here, we have a dropdown, we have an overall distribution, and then we can look at that distribution by the cluster or fan segment, which is another cool analysis we can do here. Now, I also mentioned there were two ways to deploy a model, and I'll just go back to the flow to show you. So the first one, you could deploy this cluster, the fan segmentation model, to just take your data set input and then just output a data set where you've written those cluster labels as shown here. So this is one way to deploy. a model that does segmentation, sports context fan segmentation. And then the second way is to actually train the specific clustering model. And then this green diamond, this becomes a model that we can apply onto another data set. So this is great if we're working with a pipeline that's automated. We have some training data, and now we have a model that's deployed, and I can actually pass new data sets into this model, and it will perform the same type of clustering. So that is all for the flow taken through the entire data pipeline. Now let's go back to the data set or the dashboard and kind of recap what we've built and how we got there. Some insights that hopefully the Montreal Voyageurs can take away and really improve their fan experience. So you might be wondering, actually, before I go into the dashboard, how we've built all these visualizations. This is really easy to do in Dataiku. So we actually built most of them off of this final kind of prepared and clean data set, the survey sentiment prepared. And when I double click into that data set, there is a navigation panel here for all the different pages we can jump into. And we're going to specifically go to the charts tab. And when we do that, see, this is where I've made all the visualizations. And the charts panel is a really easy to use drag and drop interface for making very aesthetic and informative data visualizations. So the first one here, what we did is we're just showing the count of records and counting all the sentiment. And how would I actually go about building this chart? Well, it's as simple as taking your data attributes on the left column, and we're just dragging and dropping them into the X and Y. And that's really it. We can change this type of visualization from horizontal to vertical if you want. It's really easy to work with, and Dataiku, of course, supports tons of different visualizations. So a few others that we built were this sentiment by winner. So we're looking at two levels, the winner of a game, and then the sentiment, and then the weight of each band you see connecting the winner and sentiment is just the number of fan surveys that went into our data set. We also created a visualization, so another bar graph where we're looking at the number of attendees, the game attended, and then the sentiment. So we can see by each game how many attendees had positive experience, had a neutral experience, had a negative experience, or a mixed experience. And then we have a few more. So the winner and sentiment, a radial chart of the final score of Montreal against the final score of an opponent by game. And then this is where we've built our KPIs. You can really add as many KPIs as you'd like here. And this is kind of a great first thing you can have on a dashboard at the top to give you kind of executive overview of your data and what's happening. And then finally, the time series chart. So all of these visualizations were in the dashboard we showed here. And the really interesting one is just this survey summaries by game, where we did our aggregate analysis. We broke down the game attended, did a summary of all our comments, and now we know exactly for each game, we can take away generally how fans felt, what their experience was like, what they liked about the game, what they didn't like about the game, maybe what they liked about the food or entertainment, and then, do something to improve the fan experience. The second dashboard here, again, we saw it in the actual visual ML lab. And we've just taken those insights and visualizations and we've put them on a dashboard. That is really all for the demo. So now you've all built your first AI project in Dataiku. And I want to thank you all for watching the demo. I'm going to pass it back to Will for a Q&A. You're on mute, Will.
My apologies. We're actually coming up on time. So we'll actually end the session right here. So Ethan, if you want to just go over to the next slide. So this is number 4 out of 15 in terms of all of our Dataiku webinars. So we're hosting a series, an enablement series in April, May, and June. As Ethan is showing on the screen right here, this is our fourth one. We've got in the rest of April, advanced data processing, coding and scripting in Dataiku. And then I think we have another 6 webinars in May on the next slide that will touch upon things like pharmaceutical, pricing, prompt studios, generative AI and AI assistance. So as your organization looks for solutions for Gen AI, definitely feel free to join our webinars and to learn about the platform and learn about all the different use cases that exist. And then there's 3 more in June around operationalizing AI, API integration, and then there's our pharmaceutical webinar in June. So thank you everyone for attending. We hope you got a lot out of this webinar. This webinar will be available within 24 hours on the Compass Analytics YouTube page, where you can watch it on demand, or you can go to our website, compassdata.ca, to learn more about everything Dataiku related and Compass Analytics related. So thank you guys for joining, and we'll see you on the next one.